as we have now studied well the angular dispersion, the concept of dispersive power, and then condition for no deviation but dispersion, or condition for deviation but no dispersion in the cases of combination of prism. So let's take some very interesting questions on these concepts. Like this example number 10. Example number 10 talks about there is a prism having refractive index 10 degree. So you have a prism with refractive angle which is 10 degree and is made up of crown glass. So is made up of crown glass, and for red and violet its refractive index R. For red color the refractive index of this prism is 1.543, and for violet color the refractive index is 1.562. Find the angular dispersion and dispersive power of the glass. So just imagine how much will be the angular dispersion. You know, angular dispersion is A into mu V minus mu R. So angle of prism here is 10 degree and mu V is 1.562 where mu R is 1.543. So we get angular dispersion as 0.19 and it is in degrees. 10 into 0.019, so it is 0.19 degree. And then we are looking for dispersive power, and you know the dispersive power is angular dispersion by deviation of mean color, or it is A into mu V minus mu R divided by A into mu minus 1. So we need mean color, and if we are looking for the mean color, we can say refractive index, mean refractive index will be mu V plus mu R by 2. So if we put all these values, we get the value of mean refractive index, that is 1.5525. So when we are looking for the dispersive power, it is mu V minus mu R. It comes out to be 0.019 divided by 1.5525 minus 1. So the dispersive power is 0.0344. So it is just a mathematical values that we have put in the relation we have obtained about angular dispersion and dispersive power, a simple revision for you to do of this concept. Now let's take this next example, which is example number 11. The question says the refractive index of crown and flint glass, blue and red rays. So just imagine one side you have crown glass, and for crown glass the refractive index for blue is 1.523 and refractive index for red is 1.513. Similarly, when we will talk in flint glass, which is little more denser, optically denser, the refractive index for blue color is 1.773 and refractive index for red color is 1.743. Calculate the dispersive power of the two glasses. So, as I have said you earlier also, that if we are taking in the spectrum the Vibgyor, violet and indigo, these are the colors which mostly get scattered in the early part of the atmosphere, Earth atmosphere. So the major color which you get are the major color which we get in the sun spectrum are blue, green, yellow, orange and red. So in case if we are having violet, refractive index of violet present, no problem. We can say mean refractive index as mu r plus mu v by 2. But in case if we are not provided refractive index of violet or indigo, we are just provided refractive index of blue also. There also we can say the mean refractive index, the mean value of refractive index will be mu b. We can take blue as one of the edge instead of violet. And similarly, in this case, the refractive index, mean refractive index will be mu b dash plus mu r dash by 2. So the mean refractive index for crown glass comes out to be like over here 1.518, and refractive index, mean refractive index for flint glass comes out to be 1.758 mu b plus mu r by 2. So 1.773 plus 1.743 divided by 2. And that's how we can get the dispersive power. Dispersive power for crown glass will be mu b minus mu r. Instead of mu v minus mu r, we can use it mu b minus mu r by mu minus 1. And for flint glass, we can say the dispersive power is mu b dash minus mu r dash divided by mu dash minus 1. So, if we put the value of mu b, mu r and mu, we are getting the dispersive power as 0.0193, and for flint glass we are getting the dispersive power as mu b dash, mu r dash and mu dash 0.0396. So that's how we can find the dispersive power, and this question was having one indication to you. One is the difference between the crown and the flint glass. The crown glass have got a refractive index, it's a clear glass, more clear glass, and it has got a refractive index nearly 1.518, whereas when we talk of the flint glass, it's a relatively optically denser glass, so it will have a refractive index 1.758, and similarly the dispersive power of crown is less and dispersive power of flint is much more. And also you learn that in case if you are given the edge color as blue, no matter, you can take mean refractive index as mu r plus mu b by 2 also. Let's take this example number 12 now. This question says focal length of convex lens, you know it, that you may have a white light coming. But if the refractive index is different for different color, then focal length is different for different color. For blue color, it may be the focal length higher, and for green, for this blue, it may be lower. For red, it is the highest, and for other colors, it is somewhere in between. So this is chromatic aberration, and let's talk about the question number 12 now. The focal length of convex lens for red, yellow, and violet. So focal length for red color is 50 centimeter. For yellow color, it is 49 centimeter. For violet color, it is 48 centimeter. So we have this relation 1 over fr is equal to mu r minus 1 into 2 by r. 1 over fy is mu y minus 1 into 2 by r. And similarly 1 over fv, violet color, it is mu y, mu violet minus 1 into 2 by r. Find the dispersive power of the material of lens. Now we are interested to get the dispersive power of the material of lens. How we will get dispersive power? Dispersive power will be mu v minus mu r by mu y minus 1. You know, the mean color can be said to be y, violet, yellow color. So I can write mu r, mu v from here as mu v minus 1 will be 2fv by r. So mu v will be 2fv by r plus 1. This way can we call it. And similarly mu r and mu y. So dispersive power will come out to be 2fv by r plus 1 minus 2. Can we write it 2fv by r plus 1 minus 2fr by r plus 1 divided by 2fy by r plus 1 minus 1. So we are getting the dispersive power from here. This 1 will get cancelled here. This 1 will get cancelled here. And this 2 by r also get cancelled. So fv minus fr by fy. So fv or fr, which is highest, 50 minus 48 divided by fy, 49. So it is 2 by 49. This is giving you the dispersive power of this lens. The dispersive power finally for the lens that you will get is 0.0408. So that's how we can obtain the dispersive power for this lens. So let's have this example number 13. And with this example, you will really appreciate the way we are using the previous concepts that you have already learned to add to this new concept of different refractive index for different colors. Like question says, there is an object appears to be raised by, so you just imagine you have a glass slab and this glass slab has a thickness 2 centimeter. This glass slab has a thickness 2 centimeter. First, the object which is here is seen using the red light. The object appears to be raised by 0.4 centimeter. It means the shift is 0.4 centimeter when we are using the red light. So I can say apparent depth is equal to real depth by mu. Apparent depth is 1.6. Real depth is 2 by mu r. So I can get the refractive index of red color 2.2 by 1.6. And thus for red color it is 1.25. Second, the same object appears to be raised by 0.7 centimeter. It means appears to be raised by 0.7 centimeter when using violet light. So I can say apparent depth is equal to real depth by mu or mu violet. Apparent depth will be 1.3 now, 2 by mu v. So mu v will come out to be 2 by 1.3 and thus for violet light it is 1.538. And next, if the refractive index of the yellow color is 1.394, so for yellow color the refractive index is directly given 1.394. Calculate dispersive power of the material of prism using the same glass. So if the same glass was used in prism, what will be the dispersive power? You can always say it will be mu v minus mu r by mu y minus 1. You can obtain mu v, mu r, mu y. So if we put all these values, we get dispersive power 0.73. So this is example number 13. And again I said, you may appreciate the way we have tried to introduce here the different refractive index of the material of glass used in that prism. Now let's come to this example number 14. It's a combination of two prisms placed invertedly. There is a thin prism P1 with an angle. So first one is the prism P1 with an angle 4 degree. Angle of prism is 4 degree. And it has refractive index, mean refractive index, which is 1.54. It is combined with other prism P2, another prism P2. And it has a refractive index 1.72. So you can say first one appears to be a crown glass and second one appears to be a flint glass. How much should be the angle so that no deviation? We can get dispersion. We want dispersion but no deviation. And for that, how much should be the value of A2? So, if we are talking of deviation, it will be net deviation will be A1 into mu minus 1 plus deviation in second will be A2 into mu 2 minus 1. And we want no deviation. So, A1 is 4 degree and mu 1 is 1.54 minus 1 and A2 we want and mu 2 is 1.72 minus 1. So, we get A2 which is minus 4 into 0.54 divided by 0.72. So, we are getting it minus 3 degree. Yes, we will get our answer in degree because A1 is there in degree. Simple question. Just it reminded you condition for no deviation. Yes, dispersion we are not talking about in this question. Let's take example number 15 now.